Welcome to the Exeter OEMX video. Today we're going to talk about using the FMECA export function in the ARCHx tool. ARCHx is one of the tools in the OEMX suite. Its primary purpose is to perform a functional safety evolution of design, failure mode, and effect analysis called DDMA, Design, Deviation, and Mitigation Analysis, and gather information needed for an FMEDA. In order to be considered a natural evolution of a conventional DFMEA, of course, DDMA must perform the essential functions, like finding a problem in a design, where in an architecture design where problems can be found very early, which saves rework time and schedule, recommending mitigations in a design when they're necessary, and of course documenting the whole design verification activity. DDMA goes one step further by gathering the information needed for a good functional FMEDA, and DDMA spends a lot of time working on increasing design verification value and quality. Any unnecessary time-consuming items from the conventional DFMEA are eliminated, and ARCHx provides much faster ways to enter the information. ARCHx mostly accomplishes this, however, by providing expert knowledge to achieve faster, better DDMAs. And I'll just repeat, while a conventional FMECA style spreadsheet is not needed for functional safety, there are contracts and some company procedures that do require one. So we provide this pretty convenient FMECA style export function. ARCHx does this by using a common FMEA format as a starting point, and of course it can be edited and cleaned up by any spreadsheet tool as required by specific company needs. How do we do it? In the ARCHx or the OEMX main menu, you hit the Report button, and FMEA Export is the second item on the list. You hit that button, and the ARCHx program begins to export your spreadsheet. It asks you for a name. It will save it and then bring it up in your spreadsheet tool. Now, how in the world do we convert from OEMX into a spreadsheet? Well, first of all, project detail information is entered into the screen is entered into the spreadsheet and the spreadsheet header. Information describing each design unit is exported into the spreadsheet line. The deviation node editor screen provides the failure mode information as well as descriptions. There is a place for potential effects for those who need that. It's not required for functional safety, but if you wish to enter it now, you may, or you can enter it later in your spreadsheet. Cause, in the context of a design DFMA, is usually something you can't do anything about. And causes are valuable if the cause can be eliminated. However, as part of the design optimization, we go through a few iterations, and we don't know typically at this point if the cause can be eliminated, but many of them cannot, like random hardware failure. You find a way to eliminate random hardware failures, and you'll be a rich person. If you need that information in your spreadsheet, you can enter it now in a simple pull-down list, or of course you can enter it later. RPN numbers were created in the FMEA world to establish priority in huge, large FMEAs. And that was really valuable back then. 3 numbers are chosen, they're multiplied together to get a risk priority. Problem is, over the years, many experienced FMEA analysts and their management complained that in the context of a DFMEA for a design, an architecture design, this was very time-consuming, and many of the hours were spent discussing why it should be a 4 or a 5 or a 6. And if you don't have a rude facilitator who tells you to stop, this can really consume a lot of time. Naturally, a solution to the problem has evolved where only 3 or 5 choices are made. RPN numbers are not needed for functional safety, as the whole functional safety mechanism has alternative, more precise quantitative mechanisms for this. But if you need this, we can use those precise mechanisms to generate some of these numbers for you. The potential impact on the deviation node editor can be used to generate one of 5 numbers, depending on the impact failure modes from 61508 that you enter. Cool. Likelihood, if you need that number, can be entered into with a quick pull-down list, and will automatically generate appropriate numbers for your occurrence or likelihood. You don't have to do that for functional safety, but it's a good way to enter that number rapidly right now. You do not want to get bogged down in debate. And perhaps most importantly, in the functional safety world, we estimate diagnostic coverage factors for each specific automatic diagnostic. And we can enter those numbers for each specific line based on a pull-down menu list or the number entered into the diagnostic coverage. It can be done. Now, it's a good start, at least, and I'd like to show you a quick demo of the ARCHx tool. Now, we have assumed in this particular video that you know how to use the ARCHx tool. If you don't, please look at our blogs, the white paper, and the video on getting started with ARCHx. Meanwhile, I'm going to launch the ARCHx program, and it may take a minute or 2 to load, but I'll bring it right in. This one came up very quickly. I'm going to load a file, the test file that I used for FMECA, and it's got 3 units, a power conditioning module, a voltage regulator module, and an undervoltage diagnostic monitor module. I've entered the deviations and the mitigations. The primary mitigation is, of course, the undervoltage monitor. Just to show you what that is, for a noisy power supply, this is, you don't know if the low voltage is going to detect, so we gave it a low. But for 0 volt conditions and for low voltage conditions, it's a much higher level of diagnostic coverage. These are all monitored on a per deviation basis. Now, all we have to do then is go to the reports. I'm going to hit the export button. I'm going to enter, let's see, we're going to call this FMEA T4. And I'm going to let OEMX do its work. The Excel spreadsheet comes up pretty rapidly, and we can see a good framework here. Personally, I think it needs a little cleanup, but I can see all the information we entered into the project up here in the header. I can see all the units listed, the failure modes for each unit. This is great. The function, the failure modes. We entered a few potential effects, so the ones we entered are listed here. We did put some potential causes down here. I see there's nothing in current risk controls. I'd like to clean that up a little bit. The primary mechanism is we have a functional safety development process. We could enter that in if you feel if your procedures require that this be there, because that is the primary risk mechanism for all of these entries. Good. Now the actions taken is we're going to implement mitigations, and if you want, we'll just make these any mitigation that we put in here we're going to implement, or we wouldn't have selected them. All right, I think this is looking pretty good. I'd like some of my lines to be a little fatter. And you can see severity, occurrence, and detection numbers have been created based on the entries we made in OEMX. I found this to be really helpful. Now, some people say this is the resulting, not the initial. So if that is true, you could go ahead and copy these numbers into the resulting and do any other modification you feel you need to do for your cleanup. Now, this is just great. Wow. I like this tool. And I'd like to invite you to play and learn. If you have a demo, you can request a demo version that includes all of the applications if you would like some. One, please send an email to oemx@exeter.com and ask for your 30-day version. If you have any questions about the tool, don't hesitate to send your questions in to that same email address, and we'll try to get you a pretty quick answer. I look forward to the excitement you get from using OEMX, and I hope you enjoy it as much as I did.